All right, great. Sorry, my voice is going, so if my voice goes in and out, I apologize. My name is Neil. I am a director of product at Weaveworks. How many people have heard about Weaveworks? A few people, all right. The topic today is pipelines. We want to talk about pipelines, particularly the difference between CI and CD pipelines. They are different. And you know, there's a lot of people talking about, hey, I do CI, CD, and that's where the challenges come in. All the CI people want to do CD, and they don't realize that CD is a completely different animal than the CI, and it's not that easy to do both really, really well. You can do one well and do the other well, but doing them together, it's extremely hard. And we'll walk through why that's hard. A little bit about us. We were founded in 2014. We're in 3 locations, and we have a bunch of Google SREs. That's how we started. We started with WeaveNet. Basically, it's a Calico, alternative, if you will. That's how the company got started, and we have morphed since then. We now run on top of Kubernetes, where we don't deal with much on the networking layer. It's open source. We support open source. But we have like several open source projects out there, Flux, Scope, all of those types of things. So we're very, very involved in the Kubernetes and Prometheus communities. So that's how you probably know us. We have a commercial product called Weave Cloud. That's the one that I manage. Okay. Before we dive in a little bit into what pipelines are, how many people here have a software title of DevOps engineer? Okay, 3, 4. How many people are here called software engineers? All right, that's not a DevOps engineer. All right, cool. Then what are the rest of you guys? SREs? Founders? Okay, cool. It's a bunch of different people. Okay, so let's get into pipeline. What's a pipeline? Anytime somebody talks about pipelines, like you have to think about a generic term, because pipeline is a very generic term. So what does pipeline actually mean? So I like to put a definition up right away. People can agree or disagree with what that definition is, but better to put one up, put a stake in the ground, and define what it is before we start talking about what it is. So to me, pipeline is just a visualized workflow. It's a workflow that moves a workload from your Git repo, app code repo, all the way to running in production. That is a complete pipeline. Pipeline is not moving into dev and stopping. Right? The workload is not visible to anyone. They can't use it in production. You can't scale it out. That is not a complete pipeline. You can call that a partial pipeline, but it's not a complete pipeline. So that's how we visualize a pipeline. But it's not enough, because even if you have a pipeline, just putting it up there doesn't do you any good, because you can't interact with it. So the key is developers and operators have to be able to interact with it at any time, at any stage that workload is moving through that pipeline. And there's lots of challenges with that, as you will soon see. Because it's important for developers to understand that I'm deploying my workload. I want to know what the heck is happening when I'm deploying my workload. And if there's any problems, I want to be able to figure out how to decide what those problems are, if there's even a problem, and then how to go about debugging the problem when I discover that. And so we need to be able to show that to them in real time. Now you multiply this by thousands or hundreds of thousands of workloads that could be simultaneously being deployed by teams, by members of teams, and by operators who are managing the clusters, knowing what the hell's going on in my cluster at any given time. Right? So this is where it creates a big challenge. And there's no one answer that's going to solve it. I don't have a solution off the top of my head. Right? It's problems that we need to deal with, and we are trying to address those problems. And that's kind of the core of what the company is about. Okay? If you can't visualize those workload deployments, then how do you know if something is actually broken during a deployment? CIs are great. CIs go, all right, I'm going to deploy it, and they treat the CD deployment as a black box. A lot of CD tools treat deployments as black boxes. You can't peek into them. You don't know what the hell's going on in there. And so those are some of the issues that we're dealing with. And that's the ones we want to address. So let's take a look at a typical CI pipeline. Here's a typical CI pipeline. Other people may have other things, but here's a simple one. Developer has read-write access, to the CI system. The CI system has read-write access to the Kubernetes API. Okay, and the container registry also. So developer has read-write access to everything, basically. Now imagine that. The developer's going, yeah, I'm going to do my deployment. I'm going to directly talk to the Kubernetes API, push something. His team member has no idea that he's working on and updating the code in the Git repo at the same time that he's trying to do a deployment, right? All these things get problematic. Now you have a CI system that's going to have full access rights to that Kubernetes API. Is that a good idea? Right? There's challenges associated with this. What happens? Okay, what we call this is an anti-pattern. Right? This is not something that CI systems should be able to do. CI systems can run their builds, they can run their tests, which is awesome, but then they're followed by a deployment directly into Kubernetes. The levels of sophistication here on how this can be done, it can vary quite a bit, right? And of course, most of the time the deployment is done in the final steps, which is that's the complexity part of the process. It's sort of end of a very complex pipeline. There's also although the implementation details can vary. Some folks will use kubectl set image. Other people will use Helm upgrade. Other people will use KSonnet. There's all these different things that people will have to use. And all of them are sort of changing the cluster. You can have your own in-house solution, in-house templating solution to do this. What people use doesn't really matter. That's really the irrelevant portion of it. But the method itself is broken. We've been calling this CI ops, right? That's what people try to do with this. But it poses multiple challenges. So let's look at some of the challenges that it poses. Okay. Now let's say that someone uses a hosted CI product like a Travis or a Circle CI, and they want to deploy these apps from CI to Kubernetes. First problem is going to deal with security. Okay. To do this, they have to give the CI access access to the Kubernetes API. They got to pass, which this poses a security risk. We wrote a whole blog post about it, so I'm not going to go into details about this because we talked about it a lot. There's also means that they have to ensure that each CI job has to be configured correctly to deploy to the right cluster, okay? And it has to have up-to-date credentials. The other problem is that they may attempt to sort of limit access by restricting it to a single namespace. That's what they could do. Dedicate to one particular app. But such credentials are even harder to manage. All right, as there's no tool currently that can manage Kubernetes credentials with the limited scope and can configure the CI at the same time. In cluster ops, you could potentially actually go in and deploy CI inside a cluster. You could go do that. Then how do you deal with multiple clusters? How do you deal with storage issues? Where do you store your logs? What about the resource consumption in there just for your CI system, right? What happens if that cluster goes down? Then what? Those are some of the other things we deal with. What if deployment updates don't go as planned? How do you deal with rollback issues? The CI system is not dealing with any of that. What if you have multiple CI jobs deploying the same version? Okay. What if someone got the config wrong? And CI job happens to override somebody else's deployment. The one thing is that the Kubernetes cluster has no knowledge of the source of truth, right? It's just running what's already been deployed in there. So if the cluster goes down, where's that source of truth going to come from? That's one of the other things. And if you lose your production cluster, yeah, pretty serious problem. Okay. So we think about it in terms of moving to a GitOps-based CD pipeline. Right? You could have a normal CD pipeline, but we think about it as a GitOps-based CD pipeline. And what does that mean? First thing it means is that we store everything in Git. So we have a separate repo for a config repo. You can have the config repo be with the same repo as the code repo, but we recommend you separate them because people can change the configuration for whatever they want to deploy, and it goes through a normal pull request process. Just like you would do for any code changes, you would go through config changes. When the PR is merged, it will trigger off a deployment, right? But now I have complete audit trail in Git. I know who did what commit SHA was there. We automatically tag the images based on your branch and the commit SHA. If you don't have your own tagging policy, you can have your own tagging policy if you want, and then you can use that tagging policy to decide how you want to deploy things. Right? I'll go to the next screen and talk about that. But basically, we have a separate GitOps operator that's running in there. It's the only one that has read-write access to the cluster. So the CI doesn't really talk to it. Any config change will go through the config repo, and the GitOps operator will deploy it. Right? That's how it's worked. Now, what Weaveworks does is a little bit different. We also have an image tag sync operator there at the same time. And this is important because now you can have a policy there. You can decide that however you want to label your container images, you can filter based on that policy. So we have 3 supported ways to do that. One is you can just have a wildcard character, like you can look at your tags. The other way, we support semantic versioning, so you can look at semantic versioning as a way to use your tag filters, and we can base it on that. And we just in the process of releasing regex, so you can do a full regex expression if you want to use to decide how you want to roll this out. So that's how you can control this, right? You can have your own, and you can have complete automated control over this, or you can do manual deployments as well. Automated deployments can happen as soon as somebody makes a config change and that PR is merged, right? It will automatically trigger based on that, based on your policy. Run that. Now, one of the big challenges here is that what if the cluster completely goes bananas? It dies, right? What happens then? Well, this actually happened to us about 2 years ago. Okay. It took us about 20 minutes to come back online. And most of that time had to do with internal communications. Why? Because we had set up a CD pipeline like that. Because we had the Git repo. Because we could recover everything automatically. Right? We were up in production very, very quickly. I think from the time it was noticed at 10:52 to 11:56, we were up and running. But CD pipelines have its own problems. It's a lot of black box problems. You don't really see stuff underneath the covers, right? We don't see what's happening with the workload during a rollout process. CI systems can't do that at all because they have no idea what's happening under the covers. Why is my workload taking so long? When Kubernetes deploys it, there's no sense of like failure. You have health checks you can check, but Kubernetes keeps redeploying it, right? How do you know it's stuck somewhere? You could put a health check, or you could put a trigger or something like that, and you could do it that way, but that's what you have to see. And then, of course, you want to see when you are deploying it, is it affecting your resource consumption in real time? Those are the types of things you want to be able to see. I won't go into all of these, but these are some of the problems we look at. And you kind of want to see what's happening with multiple workloads at the same time. Imagine hundreds of these by different team members. Okay. Imagine the operator wanting to look into it and seeing what's going on with their cluster. Some way so you can look at it, sort of peek inside the hood that way, right? Now, if you're an individual developer, you can go run kubectl command and see, where my pods stand, or you can run, some debugging commands. But if you're one team member out of a team and multiple teams with multiple workloads, well, that becomes very problematic. So how do you scale that in terms of management? That's a big challenge. So we sort of figured out, okay, maybe we can kind of come up with a prototype of what that would look like. One thing that we said, okay, this is not a product, by the way. it's just our view of what we think we wanted to see would work or not work. So we wanted to sort of show what's happening with the workloads in real time, so we can see old pods going away and new pods coming up, and there's sort of a release paradigm that we can kind of see every single workload, that is what state it's in. And you can drill down into finding more details about it. So that's kind of what we're thinking, and the bottom graph basically will show you actual resource consumption while deployments are happening. Is it changing your deployment, your CPU load? Is it changing your memory consumption? So you know what's happening with it at any time. One of the big things that we've done is sort of integrate the monitoring aspects into the deployment aspects of it, so you can see things in real time. Okay? That's it. We basically have two products. Those are two products we offer. I won't go into too much detail on that. This is where WeaveCloud actually sits. So you can get a sense of where the product sits. And further reading, we have lots of blog posts written about this. Feel free to check it out on our blog. Our engineers, Ilya, thanks to Ilya, by the way, he's the master, and he's the one that coined the term CIOps. So I give him credit. Thank you. Any questions? No questions.
All right. So how do you know that, let's say you deployed, you have a new version, it's supposed to go out. How do you know whether you actually completed deploying or rollback? Is there any way the developer can find out? Yeah, so one thing what we do is that because we collect metrics out of the box automatically, we know like when the workload is running, the workload page automatically gets created and the metrics show up for the workload. So we can see it. We also have, when we do that in the graph itself, we'll show you a deployment event. So we'll know that, oh, this is when the deployment event occurred, and this is when the pods are back running and it's fully available now. Now if that workload page is essentially blank or there's no data coming to it, we know that, hey, it's still stuck. It's still stuck deploying. But can I track it down back to the version control to get? Yes, because one of the things is that we can look in the on the release page. There's actually the actual commit that you can trace it back to. You can go look at the logs and you can trace it back to the specific commit. Thank you.
What's the life of your container registry?
Sorry?
The container registry, you mentioned there's the ability to use semantic versioning. How far back does it go, or just infinitely?
You can, we keep history going back as long as you want. Okay. Like, you can, one of the things we have is the ability to, if you don't like it, you can always roll back manually to any version previously. Okay. And that's something that's available right off the box. Yeah. And you can use any container registry, by the way, as well. We use K, but choose your container registry, choose your CI. We don't really care. Okay.
And so for rolling back, it's just a single application?
What do you mean, a single application?
Like for one application, I have that Git repo, and then basically I made a commit, and then I find that maybe something wrong with it, and then when that is just single application.
Yes. If you think about it as one repo for your code, however you decide that, and there's a release associated, there's a config repo associated with it. Right? So if you have a separate config repo, then we will know that this repo is associated with that. And if you release something and you want to roll it back, we track the versions. You can go back as far as you want. And we know like which commit, which branch that you want to roll back to, because you have a list of them. We'll show you the list of the deploys that we've done automatically. And then you can decide, hey, I want to roll back to this specific version.
Okay, so is it possible to roll back to some point where I may have different applications that are running, like for a point where application A is that version and application B is that version or something like that?
Yeah, so you have to do them individually.
Oh.
Right? Because it's not like for us, we treat, so a workload can have multiple container images, right? And so you can do it on a single container image by image level. The granularity is that at that level. So if you decide that I will roll back a particular workload that contains 3 container images, all 3 of them will roll back to the previous version. Right? You can also decide that I want to roll back this specific container image to a previous version.
Yeah.
Right? And so you can do it that way as well. And then you, of course, then the complexity also arises when you're doing Helm charts. Now, for Helm charts, we don't have a way to sort of take the internals of the Helm charts and roll back the specific things within the Helm chart. Right now, when you roll something back that's a Helm chart, we'll roll the whole Helm chart back. Okay. So that one still needs work. We haven't figured out. I mean, it's just a matter of implementing. But yeah. But for right now, normal Kubernetes workloads, yes, deployments you can roll them back to the previous version.
So, that question. I mean, let's say you have 4 different images, and I knew the combination will work. And I knew which combination worked in the past, like version 1.1, blah, blah, blah.
Yeah.
Do you maintain that relationship or the combination of the relationship?
Yeah, so we have this feature called batch deployments. So in batch deployments, you can say, I want to deploy these things together. Right? And then if you wanted to roll it back, we could roll it back for that batch. Right? So that's an option that's available.